In this problem, we want to differentiate implicitly and find the slope of the curve at the particular point. So remember that the slope of the curve is the first derivative of y with respect to x. So we'll be looking for dy dx, and we'll be plugging in the values x and y that we were given. So before we start plugging in, let's take the derivative. So I'll use the product rule on the first term, and that's the first, x, times the derivative of the second, which is 3y squared, times dy dx. So remember, whenever you're differentiating something with a y in it, it's always going to be followed up with by dy dx. Plus the second, which is y cubed. I'm not differentiating y, so I'm not going to put a dy dx here. Times the derivative of x, which is just 1. Now let's go to the next term. So we have minus, and I'm going to put all this in parentheses, and then I'll distribute the negative at the end. So let's see, we have x to the fifth is the first, times the derivative of the second, which is 2y dy dx, plus the second, y squared, times the derivative of the first, which is 5x to the 4. And that's done. Equals 0, because you have a constant on the other side. So now what I'll do, to make this a little bit easier on myself, is I'm just going to plug in the -1 for x, 2 for y, and then we'll leave dy dx as my only variable, and then I can easily solve for that. So that means we have -1 times 3, times y squared, so that's going to be a 2 squared, times dy dx, plus y to the third, so that's 2 to the third times 1 is just 2 to the third, minus x to the fifth is a -1 to the fifth, times 2 times 2, so 2y, so that's 2 times 2, times dy dx, we don't know what that is, plus y squared times 5 times x to the 4th power equals 0. All right, so we've got a -3 times 4 is -12. dy dx, I'm going to switch and just put y prime. It's a little quicker to write. And now that I don't have any y's, I'm not concerned with getting confused. Plus 8 minus, in parentheses, -1 to the fifth is a -1, times 2 times 2, so that's a -4 y prime. And then we have -1 to the 4, which is right here, which is a +1, times the 5 gives me a +5, times 2 squared gives me 20. So this is a plus 20, and that all equals 0. So now let's distribute this negative sign, and that gives me -12y prime plus 8 plus 4y prime minus 20 equals 0. Now, -12y prime plus 4y prime gives me a -8y prime, and 8 minus 20 is a -12. So I get -8y prime equals +12. That gives me y prime -12 over 8, and that is a -3/2. Final answer. So that's that problem. Now let's take a look at number 34. And what does that say? So in number 34, again we're differentiating implicitly, and I have xy plus x plus y minus x squared y squared equals 0. So let's differentiate. Again, the product rule. We have the first times the derivative of the second. I'm just going to go ahead and make that a y prime. Plus the second times the derivative of the first, and the derivative of x is just 1. Derivative of just a plain plus x term is just a plus 1. And the derivative of just a plain y term is a y prime. Minus, now again we have to use the product rule. I'm going to use parentheses here. So it's the first times the derivative of the second. So just be really careful that you differentiate between the y and the y prime. Don't lose those primes. Plus the second times the derivative of the first. And that all equals 0. So now, let's see, I have x, y prime plus y, oops, here we go, plus y plus 1 plus y prime. And now I'll distribute, and I get a minus 2x squared y times y prime minus 2x y squared equals 0. So notice that I have a y prime in this term, a y prime in this term, and a y prime in this term. So I want to get all the terms with a y prime on one side and all the other terms on the other side. So let's see, the ones I have underlined in blue, those will be the ones that we keep on this side. And the ones that are in red, I'm going to bring over to the opposite side. So we have x, y prime, plus y prime, minus 2x squared y times y prime equals, and now when I move all the other terms to the opposite side, they'll be opposite in sign of what they were. So it's minus y minus 1 plus 2xy squared. Now I'll factor out the y prime. That gives me x plus 1 minus 2x squared y equals negative y minus 1 plus 2xy squared. And y prime equals negative y minus 1 plus 2xy squared over x plus 1 minus 2x squared y. And that is my final answer.